Hello everyone. Today I'm going to talk about types of hashing. We already made a video on hashing, and in that we were discussed what is hashing and what are the terminologies of hashing. We already seen. Continuation to that, we'll talk about types of hashing. Right. So now before we step into this, let's understand now what is hash table. Hash table is what? Hash table will be having a location or a value. Hash table will have location or a value and keys. Now what this hash table will contain? Hash table will contain all the keys to will store all the keys in hash table by evaluating the hash function. We'll evaluate the hash function, and this hash function can be written, or hash function will be executed or evaluated in following methods: division method and folding method, mid square method. These are the methods. So I'm taking division method to make this video. So I'm executing a hash function, or I'm evaluating a hash function based upon division method. Using this method, I'm going to store my keys into hash table. Okay, right. So now let's see what are the types of hashing. There are two types of hashing: open hashing, which is also called as closed addressing; closed hashing, which is also called as open addressing. And before we talk each one, let's see and let's understand one example. The example are: k is equal to my keys is equal to 6 comma 16 comma 36. I took these three elements. Now these three elements I wanted to place into this hash table. Now, so when you are given with the keys, you have to evaluate hash function in order to place these keys into the hash table. Right? Now let's see. Now what is my hash function? Division method. Now division method is h of k is equal to ki percentile m, where my m is equal to 10. M is what? Maximum size. Now I is equal to what? I is equal to 0 to m minus 1. Now let's see. So what is this ki? Ki means k of 0. What is the 0th element of key? 6 element. Now k of 0 is equal to ki, that is what? 6 percentile 10. So when you are performing modulo operation, remainder will be the result. So when numerator is less than the denominator, now numerator will be the answer. So now here 6 is the answer. That is 6 element. This is my key. 6 is my key, which has to be available in the location of 6. Now find out the hash table. Here it is our hash table. In my hash table, find out the 6 location. To store 6. 6 is my key. Okay, right. And the next k1. What is my k1 now? K is my key and the first key. So 0th key is 6. 16th is my first key, k1. Now 16 percentile 10. Remainder will be again 6. Now come to your hash table. So already 6 is placed here. So again the second input is also occupying the 6th location. Now let's see even k2. K2 is equal to 36 percentile 10. Answer will be 6. Now look at this. There are 3 values are three keys 6, 16, 36, and which are locating the same location, the sixth index or the sixth location. This process is called as collision. What is collision? when the when one location is accessed by couple of keys, then that process is called as collision. Now what we have to do, we have to resolve the collision. We have to resolve the collision. That you mean collision resolution techniques. We should have some collision resolution techniques in order to overcome this problem. What the problem is? Collision. What is collision? One location is accessed by couple of keys. This is the problem, which is collision, and we should implement collision resolution techniques. And this collision resolution techniques will be implemented in these two methods. Now, let's discuss in detail on how collision resolution technique, or how collision will be ruled out, how collision will be solved in open hashing and in closed hashing. Let's look into this. Open hashing. When we get a collision in the first hashing technique, collision will be ruled out, or collision resolution technique is chaining. This is also called as separate chaining. Now, as far as the problem is concerned, the before problem, what is our before problem? So that we do have here 6, 16, 36, and we have the same location, right? Now what we are going to do is, we'll be going to implement chaining or separate chaining to place all the three elements in the same index. Now let's see the solution. That this is my hash table. Hash table. We'll take a bigger one. I have taken maximum size as 10, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So what are our keys? Our keys are 6, 16, 36, right? These are what our keys. Now for 6 we got using of division method, we got location as 6. For 16 also we got location as 6. For 36 also we got location as 6. So what we are going to do is, we'll be going to store the first element, which is 6, in the location. And when you got the second element will be in the same location, we are going to take a chain. We'll be going to take a chain from this index. Now 6 is my location where 6 is available as my key, and we'll be going to take a chain, separate chain, and here in this we'll put 16. And again 6 is the location for the third element, or for the third key. Now again separate chain will be implemented, and here it will be what? 36 will be going to put. So this is what separate chaining. As many keys we be storing in the location, that many chains we will be putting across this location. For this we will be implementing a linked list. Right? What is linked list again? It will be having two fields, data field and address field. Data field will store in 16, address field will refer this address. And again 36. It will be a linked list. Now it will be having two fields, data field and address field. Data field will be this one, address field will be next field of this. So we'll be implementing linked list as far as the separate chaining is concerned. Okay. Now let's see one example. The example 5, 3, 9, 6, 25, 15, 18. Now these are my keys. So the way of giving solution is keys ki is equal to 5, 3, 9, 6, 25, 15, 18. Now this is my first 0, 1, 2, 3, 4, 5, 6. So I'm going to take implementation for hash function, and I'm going to take one hash table. This will be for hash function, implementing hash function. Hash function, my keys ki, and to evaluate hash function, which is to give the result of location. U is my location. How to get location? That is evaluating the hash function, which is k percentile m. Right? And from this we will be getting the location, which is u. So this is my hash function. This is my hash function. Okay. So this table is respective to implementing the hash function. Now consider the first element ki. So ki means k0, k1, k2, k3, k4, k5 and k6. So we'll take these elements. And what is the maximum size? The maximum size of this m is equal to 10. This is my maximum size. Okay. Now implement the hash function. Now what are my keys? The first key is 5 and next input 3, 9, 6, 25, 15, 18. These are my keys. Now apply division method over these keys. Now k percentile m, that is 5 percentile 10. Answer is 5. And 3 percentile 10. Answer is 3. 9 percentile 10. 9. 6 percentile 10. 6. 25 percentile 10. Answer is 5. 15 percentile 10. Answer is 5. 18 percentile 10. Answer is 8. Now what all these are? Locations. Locations to place these keys. So these keys will be available in this location. Now find out your hash table. Your hash table size is what? 10. Maximum size is 10. So now your locations, these are your locations and these are our keys. So now locations 0, 1, 2, 3, 4, 5, 6, 7, 7, 8 and 9. These are my locations. Now in this locations we have to place these keys. Okay. So 5 is my key which should be available in 5th location. 5 is my key which should be available in 5th location. Now this is my hash table. Right. Now where is 5th location? Here it is. Which element has to be available? Phi element has to be available. I mean, phi is a key. And next element is what? 3. It should be available in 3 location. Next element is, next key is what? 9. 9 should be available in 9 location. Next is 6. 6 should be available in 6. Right. And 25 should be available in 5. Now this is the place where collision occurs. Collision. Because already phi is given to some key. Again phi is accessed by the 25 key element. So this process is called as collision. Now we'll be going to resolve this collision using of separate chaining. Now here it is, separate chaining will come. Now we'll be taking a separate chain. Now what we'll place here? 25 will place. Again collision, next element, and we'll take separate chain. So the element is what now? 15. Now it is 18. 18 will be at 8th place. So no collision. 18, 8th location is empty. So you can place 18. So when one location is already occupied and when it is full, when it is occupied, then only separate chaining will be implemented. So collision resolution technique as far as open hashing is concerned, or that is close to addressing is concerned, separate chaining. So we'll implement like this. We'll take a separate chain against to the location where we wanted to place the element using of hash function. So this is the collision resolution technique in open hashing. So next video we'll be going to see about how to resolve the collision when it is occurred in the second method, closed hashing. Open hashing collision resolution technique is what? Separate chaining. Open hashing collision resolution technique is separate chaining. So next video we'll be going to see about closed hashing, how collision resolution technique will be implemented. Okay, thank you all.